Hello everyone, welcome to Tech Talk Universe. Water is one of the most magical substances in the universe. On Earth, only water can exist in three forms: liquid, solid, and gas. The European Space Agency, ESA, once filmed a sci-fi short film, which was acted by Littlefinger from Game of Thrones. In the distant future, a half-human, half-god teacher gives a lesson to students. Littlefinger might be a history teacher. The teacher tells the students, water is the key to life. Without water, humans would not exist. The teacher goes on to say, why there is so much water on Earth has always been a mystery. When the solar system was just forming, there were 1 trillion celestial bodies made up of ice and dust in the galaxy. To figure out whether the water on Earth was brought by these celestial bodies, humans launched the Rosetta mission to study the comets in the solar system. Why did ESA make this short film? They wanted to say their Rosetta mission was really important. Not only did Rosetta find out the composition of water on the comet, but it also launched a probe to land on the comet. This was the first comet landing in the history of human space exploration. However, it's a pity there was a major error with Rosetta. But in the end, there was a fascinating twist. Scientists still achieve a lot of research results. Rosetta was a glorious mission despite the defeat. About this thrilling interstellar journey, we have to start from the beginning. The time goes back to March 2nd, 2004. At the Guiana Space Center in French Guiana, Rosetta, along with the Ariane 5 rocket, soared into the sky. The whole European continent was jubilant. This is not an exaggeration. Since the Soviet Union kicked off the space race in 1961, the most eye-catching space explorations were carried out by the United States and the Soviet Union. Europeans also have a strong sense of self-esteem and honor. They also wanted to contribute to human space exploration. But the European Space Agency, ESA, is far from matching NASA's capabilities. Americans had already landed on the moon in 1969. So, Europeans wanted to carve a different path. After much research, ESA decided to implement a plan to land on a comet. Landing on a comet is much less challenging than a manned moon landing. And there's one crucial point. This was the first time in human space history. No one had ever done such a thing before. Just at the beginning of 2002, the Euro was officially launched, and the Eurozone was formed. ESA wanted to immediately start this project, using grand space exploration to unite the spirits of EU member states. That's the background of the Rosetta mission, a scientific research project that was given political implications. It tends to be somewhat hasty. From the moment Rosetta set off, there was a bit of congenital insufficiency. We'll talk about this in detail later. But Rosetta still gritted its teeth and set off. It not only carried the glory of Europeans, but also attracted the attention of astronomy enthusiasts around the world. Like all space missions, Rosetta needed to use the tremendous gravity of a planet to accelerate. In 2005, Rosetta, aided by Earth's gravity, headed towards Mars. In 2007, it needed to continue using Mars as a gravitational booster. But at this point, the risk of failure had already become apparent. To achieve faster acceleration, Rosetta had to take a significant risk. Entering the orbit of the planet, getting as close as 250 kilometers to Mars. For a full 15 minutes, the probe was completely in Mars's shadow. The temperature would drop to near absolute zero. Without solar energy, it could only use the onboard heater for warmth. At the end of the last century, battery technology was not yet mature. If the battery ran out at this time, then all efforts would be in vain. ESA's technicians had no confidence. They called this voyage a €1 billion gamble. As 15 minutes were about to pass, Rosetta's battery power was already very low. People in the control center were very nervous. When the signal came back, people jumped with joy. But by this time, everyone already knew clearly. Rosetta's solar cells were not working well. The battery issue lingered, casting a shadow over the entire mission. 2 years later, in November 2007, the probe flew past Earth again, 5,700 kilometers away from Earth. 2 more years passed, and in November 2009, Rosetta made its third flyby of Earth, accelerating repeatedly under the effect of the gravitational slingshot, finally reaching its scheduled speed. Rosetta started heading for comet 67P. It would enter orbit when 67P was at its farthest from the Sun. To conserve power, 2 years later, The control center shut off Rosetta's power, letting it travel alone in the vast expanse of space. In the blink of an eye, 3 years hurried by. Rosetta was already very close to 67p. Now it was time to wake up Rosetta. The second test was coming. The time came to January 20th, 2014. At around 4 a.m., people began to arrive at ESA, located in Germany, the Operation Control Center. The program was set to wake up Rosetta around 6 a.m. that day. Then the antenna on the probe was to be realigned toward Earth. Large radio telescopes in California, USA, and Australia were all ready to receive signals. The control center was filled with reporters from various European countries. They were all waiting for the results. Rosetta's flight commander, Italian scientist Andrea Accomazzo, was under tremendous pressure. He was the first person responsible for flight control. The time for signal reception had already arrived, but no matter how long they waited, the signal didn't come. Several hours passed, and there was no change on the signal oscilloscope. Some people began to lose their patience. Rosetta had flown 700 million kilometers in the cold of space. Its solar cells had not been turned on for 3 years, and no one could guarantee that it wouldn't fail. By around 6 p.m., the wake-up time had passed a full 12 hours, but the signal still hadn't come. Rosetta's chief scientist, Frenchman Jean-Pierre Bibring, hinted in an interview that the mission might fail. British astrophysicist Matthew Taylor swore in an interview, as long as Rosetta could be awakened, he would tattoo Rosetta on his body. Everyone was unwilling to accept failure. By 7 p.m., 13 hours had passed, and still no signal. Time passed by every minute and second. At 7:18, the command hall was dead silent. You could hear a pin drop. Just then, a buzzing sound came from the speaker. This was the sound of Rosetta establishing a connection. There was jubilation in the control room, people excitedly embraced each other, and the hall outside also erupted into enthusiastic applause. Rosetta had made it through. The mission hadn't failed. All of Europe breathed a sigh of relief. The main problem was still the battery issue. Because the conditions in space were so harsh and the temperature was close to absolute zero, the battery's charging efficiency was greatly reduced. Rosetta was far from Earth. A light signal transmission would take half an hour. The result was that the wake-up signal took a full 13 hours. To keep his promise, Taylor immediately went to a tattoo shop and got a tattoo of Rosetta on his leg. The media treated this as a fun story and aired it on the news. It is said that across all of Europe, thousands of people choked on their breakfast when they heard the news. But this incident also gained Taylor countless fans. The media called him the coolest scientist of the year. The time came in May 2014. Through multiple foundation-laying maneuvers with the onboard thrusters, Rosetta finally entered the predetermined orbit of comet 67p. Scientists could finally see the comet through a camera. Listening to Jean-Pierre Bibring's interview was particularly interesting. He said he was afraid that when they turned on the camera, the comet wouldn't be there. It was only when he saw the comet with his own eyes that he felt reassured. This was another victory for Newton's law of universal gravitation. This confirms that the law of gravity is still true in our solar system. Why would scientists feel uneasy? The reason is that we don't know what gravity is. The gravitational formula can be used for calculations, but the essence of gravity remains a mystery. This was the first time humanity had observed a comet at such close range. Rosetta brought astonishing images. 67p is a dumbbell-shaped comet. Scientists call this form a contact binary. Its size is equivalent to that of Mount Ma in China. There are cliffs, valleys, and huge cracks on the surface. Some places even experienced landslides. In order to study the composition of the comet, Rosetta was equipped with many advanced scientific instruments. There's a particle accelerator, which can collect dust ejected from the comet, a component spectrometer, which can analyze the water composition on the comet, a high-definition camera, which can capture the complex terrain of the comet. Most importantly, there is the lander Philae. Philae has 7 cameras that form a panoramic camera. A gamma-ray instrument analyzes the internal composition of the comet. A drill can recover rocks from the surface of the comet. Inside, there's also a mini-lab, used to analyze organic molecules. The first problem facing the scientists was, where should Philae land? Rosetta started to draw a 3D topographic map of the comet. Subsequently, The scientists selected 5 landing points for comparison. This was the most critical step. There could not be any errors. There are many large cracks on the surface of the comet, and a lot of water and gas would be ejected from these cracks. If Philae happened to land on a crack, that would be troublesome. It would probably get blown away. Philae would have to use 2 retractable harpoons for anchoring. The rocks at the landing site would have to be relatively sturdy. If the harpoons shattered the surface, Philae also would not be able to secure itself. This required Philae to hit its mark on the first attempt, because there was no second chance. The scientists discussed it for 2 full months before they finally confirmed the plan. The time came to October 12, 2014. This was the most crucial day of the entire comet exploration mission. Early in the morning, a large number of experts and journalists rushed to the control center, waiting for news of the landing. At 8:35 in the morning, Rosetta released Philae. Whether the lander succeeded or not entirely depended on the last operation of the ground staff. This was a photo taken by Rosetta. You can see Philae flying toward the comet. After a long 6 hours of slow descent, Philae was finally about to land on the surface of the comet. In the press hall, everyone's eyes were glued to the big screen, waiting for the victorious cheer of Commander Acomo. This would be the moment of mankind's first landing on a comet. From the launch of Rosetta in 2004 to the landing of Philae on the comet in 2014, Europeans had waited for this day for a full 10 years. At 5:03 in the afternoon, remote sensing signals showed that Philae had touched the surface of the comet. The hall immediately erupted with thunderous applause. People were very excited about celebrating each other. The spokesperson was also very excited. He dramatically took off his jacket for the audience to see, revealing a t-shirt with Philae on it. However, the happy time was very short. Only a minute later, the situation took a turn for the worse. The signal showed that Philae's status was not stable. It was tumbling non-stop. 2 hours after the impact, Philae still hadn't stabilized. It wasn't until 7 hours later that scientists slowly pieced together the truth of what had happened. There was no issue with Philae's landing. It was very precise. Its landing point was accurately within 10 meters of the target. The problem was with the harpoons. The moment Philae landed on the comet, the harpoons were not released at all. It wasn't anchoring. Because the gravity of Comet 67P is very small, its escape speed is 1 meter per second. That is to say, an adult could jump into space on a comet. So Philae bounced off the comet's surface, as high as 1 kilometer. Fortunately, it didn't escape the comet's gravity. It slowly descended, and finally rolled over to the other side of the comet's horizon. This space exploration mission, which all of Europe was proud of, was at this point half-failed. Men have tears, but they don't shed them lightly, only when they reach the point of heartbreak. Acomo could no longer control his emotions. His tears welled up in his eyes. The 10 years of life, the hard efforts of the scientists, and the sense of mission and honor of Europeans, all went down the drain. Many people in the control room shed tears. Perhaps their sorrow touched the heavens, and the story miraculously turned around. Early the next day, when Rosetta moved to the other end of the comet, it received a signal from Philae. The control staff hurriedly searched for Philae's location, but no matter how they searched, they couldn't find it. Philae has a signal, but it's nowhere to be found. The signal indicates that Philae's power will soon be depleted. What should we do? Scientists decided to use all the instruments on Philae once. The control room suddenly became extremely tense. The originally planned 5-month exploration mission needed to be completed within 60 hours. By November 14th, Philae's power was completely depleted, and communication was interrupted. Now only Rosetta, in orbit, continued to carry out the mission. Initially, Rosetta thought there was a magnetic field on the comet, and converted the collected signals into audio. It sounded like the sound of a monster laying eggs in the movie Alien. But the data collected by Philae showed the comet had no magnetic field, so this wasn't the sound of a magnetic field. Later, scientists confirmed, this was the sound of solar wind blowing over the comet's atmosphere. Such a small comet also has an atmosphere. This was a surprising discovery. By comparing the photos taken by Rosetta, scientists discovered that the large rocks on the comet are always in a state of movement. This is due to the weak gravitational pull of the comet. The rocks on its surface move around due to mechanical forces and fluctuations on the comet's surface. This boulder, with a diameter of up to 10 meters, actually slid 100 meters. Philae, on the surface of the comet, discovered more than 10 different organic compounds. Although the presence of organic compounds does not necessarily mean there is life, indeed, life is composed of organic compounds. This shows that the impact of comets on Earth could very possibly have been a way for life to originate. Initially, the comet only spewed out 500 grams of water and matter per second. But as 67P got closer and closer to the Sun, its activity became more and more intense. At its peak, it could spew out 300 kilograms of matter per second. Scientists estimate that 67P loses about 1 meter in thickness each time it orbits the Sun. In other words, about 30,000 years from now, 67P will eventually completely evaporate. On the evening of June 13, 2015, a full half year had passed since Philae's battery was depleted. Suddenly, Rosetta received a message from Philae again, showing that Philae was fully charged and no longer needed to maintain safe mode. This was because 67P was very close to the Sun at this time, and the sunlight intensity on the comet's surface had greatly increased. But where exactly was Philae? It wasn't until 3 months later that Rosetta finally located Philae using its high-resolution camera. Philae was wedged in a huge rock crevice. If you zoom in on the photo, you can see one of Philae's legs sticking out. Because of this very concealed position, communication between Philae and Rosetta was always challenging. Then, Rosetta accomplished its most remarkable mission, analyzing the moisture content inside 67P. Research showed the water inside 67P was completely different from the water on Earth. The interior of 67P was filled with heavy water, not light water as on Earth. Heavy water is water composed of the isotope of hydrogen, deuterium, which has one more neutron than a hydrogen atom. Heavy water is very rare in nature. Its ratio is not even 0.02%. The discovery of heavy water opened another door to our exploration. If comets brought the water to Earth, did life originate in heavy water? Where did the heavy water on Earth go? These questions make us realize the truth about life is far more complex than we imagined. The time came on September 30th, 2016. Comet 67P was getting further and further away from the Sun. The charging efficiency of Rosetta's solar battery became lower and lower, and it could no longer guarantee continued navigation. Scientists decided to crash Rosetta into the comet, collecting as much information about the comet as possible before the probe's life ended. These time-lapse photos are the last images left by Rosetta. These were the clearest images of the comet at the time. In the end, it crashed into the comet, and the image was terminated. From the launch of Rosetta to the end of the mission, it was a long journey of 12 years and 6 months. The Rosetta mission was a great adventure, an honorable mission despite its failure. It was a declaration from Europeans. They wanted to contribute to space exploration, so they chose a venture that no one had ever done before. Although ESA's technology was not mature, and the budget was minimal, they still pressed forward without hesitation. They knew that only through the accumulation of knowledge can humans finally reach the stars and beyond. That's it for this episode. Remember to subscribe to Tech Talk Universe's channel and turn on the notification bell so you don't miss the latest episodes. This is Tech Talk Universe. See you next time.